working on R12 homework. The first question, by the way, I only do numbers 1 through 10. The other ones we'll use for warm-up. There's 40 passengers that hire a train on a car, and it's one of those deals where you get a special price if more people come. So this is the type of problem called a maximizing profit problem. And this equation is really important to understand. It's pretty common. You start with, you have to multiply everything by x, which is the number of people going. So there's an x on the outside. And usually on the inside, you have the new cost for anything greater than 40. So it's $8 minus 10 cents for everything greater than 40. So you would use x minus 40 for that. So this is the new cost for, including the people and the people greater than 40. Okay? So simplify that to 8x minus 0.1x squared plus 4x, or 12x minus 0.1x squared. And then because you're trying to maximize, you have to take the derivative. That's the whole point of maximization and optimization and all, is taking the derivative and find out where it equals 0. It equals 0 at 60. Double check that it is a maximum. If you look at this equation right here, this equation, like if you're doing a sign chart, it's of the derivative, and you use end behavior. It's just a negative slope. It's positive before 60, negative after, so that means it's a maximum. So indeed, the maximization would be 60 passengers, okay? So let's go on to number 2. Number 2 has a fruit grower, and he harvests his crop. He'll get 100 pounds per tree. So he gets 100, let me use white. He gets 100 pounds per tree, and he gets to be paid 25 cents a pound. So for each week he waits, the crop he'll get 10 more pounds per tree, but the price will decrease by 1 cent per week. And then when should he pick it? So the reason I wrote this down is this is always like a good place to start. You take what you're starting with, and when he adds 100, he's going to, for every week he gets 10 pounds more. So make sure you understand that. This is the pounds, right? For every week he waits, and so x equals the week waits. Okay, for every week he waits, he gets 10 more pounds. And then, but that also affects the money. So the money would be, he starts out with 25 cents, but he loses a penny every week. So it's these two. This is the cost, or what he makes, price. Okay, so then you multiply that together, and you get 25 minus x plus 2.5x minus 0.1x squared. Simplifying that to 25 plus 1.5x minus 0.1x squared, we'll call this profit, right? And so P prime is equal to 1.5 minus 0.2x. You set that equal to 0, so you get 0.2 equals 1.5, so x is 7.5. Now x is the number of days after, so make sure you have to add those days to it. Okay, so here was our equation that we're going to do end behavior. Again, it's a positive, negative, because it has a negative slope of a linear equation, so it's a maximization. And so he would wait 7.5 weeks, but it also asked what would his profit be at this time. So you have to go back into this P, and substitute in 7.5. So 25 plus 1.5 times 7.5 minus 0.1 times 7.5 squared. And that comes out to be $30.63. And that's per tree, dollars per tree. So that was number 2, and I'll stop and do the next ones on the next video.